Hi, I'm Christoph Schleifenbaum. I live in Sweden and I work for Qtap. In today's video, I will talk about how to use Qt's serial bus module to communicate using CAN bus. CAN bus is most commonly known for communication between devices in, for example, cars, but is used even on other industrial appliances. I will show you how to interact with an EV high voltage charger to make it charge the battery. Let's go! CAN bus, which stands for Controller Area Network, is an industrial bus system which most people heavily associate with communication between different electronic control units in vehicles. It was developed in the 1980s. The bus system normally consists of only 2 wires and is message-oriented. Today, I will give you a short introduction into how to use Qt's Q serial bus module to transmit and receive CAN bus messages. I've mounted 2 additional AC chargers into my EV to speed up AC charging a bit. But for them to work, I have to provide them with information about how much power they are allowed to put into the battery. For this to happen, I put a little embedded device next to the chargers running a Qt program. For this to work, we first have to figure out how the chargers communicate. That means which messages they send to me and what messages they expect me to send. This is an example of how communication looks like. There are even other chargers using different specs. First of all, the baud rate of the device is important. In our case, it's 250 kilobit per second. We have to configure this in the code. Sometimes devices support different baud rates. The most important information in this PDF is the actual data being sent to and from that charger. Every CAN message frame consists of a CAN ID, which should be unique in the network, and payload data. The payload data is typically 8 bytes long. Traditionally, CAN IDs are just 11 bits long and are written as 3 hexadecimal digits. The chargers I want to program use extended CAN IDs up to 29 bits long. Further, the PDF specifies 2 message types. Message 1 is expected to be received by the charger once a second. It contains mainly the maximum allowable voltage and the maximum allowable current. Message 2 is broadcasted by the charger once a second. It contains the current charging information, the output voltage, the output current, and the charger status, which I hope is not an error. Now we are ready to look at the actual code. First of all, we need to create a QCanBusDevice. Qt's QCanBus module uses plugins for the different CAN bus backends. For testing purposes, I wrote a little plugin, ReplayCAN, which simply plays back a log file I created. If you are interested in how this works, you can check out the source code in the video description. Otherwise, this example uses the SocketCAN plugin. Once the device has been created, set the data rate to 250 kilobit per second, as the chargers expect. Now we are ready to connect the device. After the device is connected, we instantiate a TC charger controller and add 2 instances of TC charger to it. They get the sending and receiving CAN IDs as parameters. I have 2 chargers which are configured with different CAN IDs to make sure I can distinguish between them. Now let's look into how to receive messages from the bus. As soon as message frames are received by the QCanBus device, the signal frames received is being emitted. We connect to the signal and handle the frames in read-CAN frames. In there, we deliver the frames to the respective charger, identified by the frame ID, which we passed to the constructor. In TC charger's receive frame, we read the payload from the message frame. We unpack the voltage, the current, and the status. TC charger controller calls control charging once a second to make sure the charging parameters are being sent to the chargers. In main CPP, we hard-coded the requested charging power to 4000 watts. Since we have 2 chargers, every charger will end up charging at 2000 watts. Note that these numbers have to be determined by the battery management system. Since the chargers are controlled by setting the current, we calculate the current from the requested power and the voltage, and set each charger's maximum output current to that value. The maximum voltage is a fixed value depending on the battery. TC charger set max output current calls prepare and send frame in case the requested current was changed. Otherwise, it even gets called once a second from a timer. In prepare and send frame, the CAN bus message frame is put together. For this, we pass the CAN ID and a byte array consisting of 8 bytes to QCanBus frames constructor. We finally call QCanBusDevice write frame to send it. That's it. The battery should now be charged with 4000 watts of power. In this video, I showed you how to use QCanBusDevice to talk to devices on a CAN bus. I hope you enjoyed the video. If you have any questions, don't hesitate to ask under the video. If you find it useful, share it with your colleagues and subscribe to our channel to not miss the next video in this series. Hej då!